Hello, dear listening of the conference. I present to you the work Residual Stresses According During Laser Shot Processing Technology or Height Load Units of Agriculture. The increased variability and lifetime of height light agriculture manufacturing units is very important to apply various strengthening technologies to them. Laser shock processing (LSP) is an innovative technology for surface treatment of highly loaded machine units which initial power fields of compressive residual stresses (CRC) in the near surface layers of processed metal alloys. This RC is turn significantly increase this mechanical characteristics such as fatigue strength as well as corrosion and wear resistance. The LSP technology is based on scanning a metal surface under investigation with height intensity laser pulses with an intensity and a duration of several nanoseconds. The short wave in the near surface region initial of occurrence of plastic deformation as well as compressive residual stresses, which improve the surface properties of the materials. In the LSP schemes, a transparent confident layer is used to increase the pressure in the generation plasma. Since each laser pulse in LSP covers only a small part of the treatment surface in order to completely cover in the entire surface under study. Laser pulses usually overlap each other and scanning occurs in zigzag schemes. Such a zigzag scan in the simplest and easiest to carry out, but it has one significant side effect. The result regional stresses have a pronounced anisotropy. Significant difference between the volumes of the residual stresses after the LSP in the direction C, sigma x, and the duration y, sigma y, have been recorded in many works, but until now the explanation of such anisotropy of residual stress remained an open question. Only recently was the effect of LSP on the generation of dislocation, the nature of displacement of dislocation and grain refinement in deep studies, and it was suggested that it was could be related of the anisotropy of residual stressing. However, but need more systematic studies to explain the anisotropy of residual stresses. This paper explains the influence of various scanning schemes and the components of residual stresses sigma x and sigma y. To achieve this goal, the author have developed a three-dimensional numerical model using the finite elements methods (FEM), which makes it possible to simulate the LSP technology using surface scanning both in zigzag scheme and in the random scheme. The materials for the study was aluminum alloy. This is a high stress material with fiery, good machinability, which is successfully using in a wide variety of areas, from rocketry and aircraft fuselage to gears, shaft, pistons, and various fasteners. Its chemical composition is shown in Table 1, Mechanical Properties, Table 2. For 3D finite elements models of the LSP technology, the Abacus explicit package was used. It solved the physical problems of the propagation of a short wave in a solid, taking into account the special allotropic behavior of the materials. From a geometric point of view, a fully three-dimensional configuration is considered. There the strategy of sequential overlap of the investigation surface with laser pulses is implemented. Finite elements in the form of 8-knot prism, namely C3D8R, are used in the area processing by LSP. The element size is 100 to 100 to 25, which is the maximum element size that allows its convergence of calculate to the maintained. In this rest, there are the no applied alloys, the finite elements, a simple 6-knot prism, namely the C3D6T, which successfully made with the C3D8R elements. The constitute relation describes the plasma's behavior of the materials and includes the functional dependence of the dynamic Alt, stress sigma, on the equipment, plastic deformation, stress rate, and temperature. The most widespread empirical and more recently semi-empirical dependencies. Among the then for fast dynamic process, the most successful there are John Cook and Zerley Armstrong models. Due to their simplicity and the ability to describe the form of deformation curves in a sufficiently high quality manner in the weight range of temperature and strain rate, these equations are widely used in practical calculate for numeration models, in particular in the study of shock wave processes in the materials under study. The model of John Cook, which is used for the analysis of LSP, as is an empirical dependence of the dynamic Alt stress from the equipment, plastic strain, strain rate, and temperature. Equation contains 5 materials constants which determine empirically is the static Alt, straight B is the models of strange hardening, N is the exponent in the law of strange hardening, C is the coefficient of the strain rate, M is the exponent in the law of temperature softening. It should be noted that when the melting point is reached, the yield stretch tends to 0 for all deformation and strain rate. Table 3 shows the parameters in the John Cook models for the D16 aluminum alloy. There are several other models of constitutive relation. For example, the Zerley Armstrong model, which is based on the theory of dislocation, which potentially makes it preferable to the over empirical relation. More well, it is assumed that each type of microstructure of the material has its own dependence. On the other hand, a more complete form of the relation impulse or more complete ways of obtaining this constant. In our work, the John Cook models will be used. Before analysis, the situation with respect to the reduced stress arising from multiplied laser pulse, it is necessary to study in detail the feature of the appearance of reduction stress sigma x and sigma y after the shot by a single laser pulse. The result of the simulation as shown in figure A. Inside the laser shot, the reduced stress sigma x and sigma y are most the same. However, outside of the sport, this volume different significantly from each other. Namely, for sigma x, the compressive residual stresses CRC occur in the upper and lower regional or the laser shots, and the tensile radial stress TRC occur in the left and right regional of the spot. For sigma while we have the opposite picture. The CRC occurs in the left and right parts of the spot, and the TRC occur in the upper and lower regional. The residual stresses that occur in the case are the same in absolute volume but have different sign. In the figure B, shown the description of the surface regional stresses for the sigma x and sigma y after the shot on the same with 11 pulse at which the first column of pulses ends, after which the second column immediately begins. It is seen that the result compressive radial stresses along the x-axis sigma x greatest than along the y-axis. It's show the notice that this case each new pulse adds compressive radial stresses to the sigma x, thereby strengthening the material. Stress drop sigma x about 100 megapascal, and in the sigma while each new pulse reduce compressive stresses softening it's about 170 megapascals. This is due to the superposition of the regional stress occurring outside the spot. Figure I. The properties of the behavior of the radial stresses fluid change sign final with the beginning of the second column of shot. It's figure C, which shown in the picture after 16 pulses. For example, for regional stresses on the x-axis sigma x, each new pulses from the second column reduce CRC, and in sigma while on the contrary, each new pulse increases CRC. Obviously, the decrease in the sigma x is associated with the additional of tensile stresses created by second column of shot on the left and right sides of the laser shot. Naturally, the increase in the sigma while is associated the additional of compressive stresses generated by the second column of shot on its upper and lower parts. Note that in the case and the characteristics of the distribution of result stresses in the vicinity of the each laser shot remains the same as after a sine pulses. Figure A. In the figure 3, show the distribution of resultant stresses flighted after 100 and 286 pulses respectively. It can be seen the trans appearance in figure in present. The composite reduced stresses are seen in the zigzag scanned scheme in the scanned direction sigma while greater than in the perpendicular direction sigma x. This feature of the distribution of resident stresses the main reason of the occurrence of finite anisotropy of reduced stresses in zigzag scanning scheme. The obtained numeral results show the methods of choosing the scanning direction has a strong influence on the anisotropy of result stresses. The particle of the it was found that with a zigzag scanned scheme of CRC and the scanning direction is much greater than in the perpendicular direction. Therefore, the choice of the scanning direction is an important separate task that should be solved before using LSP to optimize the result reduce stresses fields. Uh, if the laser pulse and the LSP are not directed according to predetermined schemes, for example shown on the figure, where in zigzag scanning scheme was initially chosen, but trigger in the random segment, then the difference in regional stresses between sigma x and sigma y decreases noticeability. This clearly seen from figure. There it is seen that the distribution pattern of residual stresses sigma x and sigma y after the application of 286 pulses fired in the random sequence are very similar. It's a B on the figure. Random sequence of pulses of numeration analysis was programmed and implemented using the VD load subroutine available from Abacum finite elements package. The difference between zigzag and random scan schemes can be visualized more clearly if the changes in the residual stresses sigma x and sigma y are graphically represented over dips in the figure 5 showed in the both comparisons. As you can see, the difference between sigma x and sigma y, which is indicated in the figure in the grid after scanned according to a zigzag scheme, is much greater than the scanning according to a random scheme. This means that which a random scanned scheme, the anisotropy of radial stresses decreases by about 100 to 175 megapascal. Analysis the result obtained. The main conclusion can be drawn that the random schemes of scanning by laser pulse of LSP is an effective solution to the problems of reduce the anisotropy of radial stresses. The results obtained show that the result anisotropy of radial stresses as a consequence of the use of the zigzag sequence of pulses, and that is due to the natural median accumulation